This is the screencast for section 4.5, example 6. We're going to look at differentials. Now, technically we've been dealing with differentials but now we're the whole time, but now we're going to look at them under a little bit of a microscope per se. A differential is a change in y according to change in x, and we've been calling the change in y dy and the change in x dx. So, for example, over here the slope is delta y over delta x, or dy dx. And so say that's 1/2 or 2/4 or 0.08 over 0.16, whatever it is, the change in y, if you multiply both sides by change in x, the change in y is 1/2 the change of x. So you get the change in y according to the change in x. So dy, the differential y, is 1/2 the differential dx. So every change in y is 1/2 the change in x. So we're going to look at that, how that applies to a situation here. Part A, find a differential dy and evaluate dy for the given values of x and dx. So we're going to evaluate the change in y given the x value and its change in x. So first I'm going to take the derivative, and this time I'm not going to write y prime because I'm using differentials. I'm going to make sure to write dy dx. So at this point, I know that the derivative is 5x to the 4th plus 37. So I know that if I plug in x equals 1, I get that the slope there is 5 times 1 plus 37, so 42. Which means dy dx, the change in y, is 42 for every 1 the change in x is. But I don't want to know the change in x for 1. I want to know the change in x when it's 0.01. So I'm going to multiply both sides by dx, and I'll be able to find the exact change in y when dx, or the x value, changes only by 0.01 from the x value 1. And as you may have predicted, the differential is 0.42. So meaning if x changes by 1, y changes by 42. So if x changes by 0.01, dy changes by 0.42. So this is the graph of x to the 5th plus 37x. So at x equals 1, right here, the x values are changing by 1, and the y values would then go up 42. So up 42, right 1, up 42, right 1. But I don't want that. I want to know what happens when it changes by just a teeny little bit, by 0.01. So then the vertical change, then, the dy, is going to be 0.42. Very, very teeny. Part B, y equals the sine of 3x. We want to know at x equals pi, what is the change in y, the differential, when dx, the change in x, is negative 0.02. So I'm going to find the derivative, and I want to find just the differential, so I'm going to multiply both sides by dx, and I get dy equals 3 cosine of 3x dx. So now I can just plug in the x value pi up here and find dy dx, but I want to know at x equals pi, when the x value only moves negative 0.02, what is the change in y, not the change in y according to a unit change in x. So basically what this is saying here is the differential is negative 0.06. So in other words, dy dx would be negative 0.06 for every negative 0.02. So the change in y is negative 0.06 for every change in x, which is 0.02, which is really just a slope then of 3. dy dx at pi is 3. So at the spot x equals pi, it looks like the slope is going up 3, right 1. Now, not totally up 3, right 1, but maybe up, 0.03 and then right 0.01, which is also the same thing as going down 0.06 and left 0.02. Part C, when we take the derivative to begin to get the differential, we're going to have to use some implicit differentiation because I have the product rule with x times y here. So I'm going to start out by taking the derivative. Now I'm going to get the dy dx's on the same side of the equal sign and factor out the dy dx. Now I get dy dx equals y minus 1 over 1 minus x. Now unfortunately I have both x and y in that expression, so to find the differential, I'm going to need to know the y coordinate. So off to the side here, I'm going to plug in 2 for x and solve for y. And I get that y equals 2. So now I can plug in 2 for y and what it seems like is 2 for x and the dx value to be able to get the differential. And I get the differential is negative 0.05, which means that for every 0.05 that the x value moves, the y value will go down 0.05. The now try problem number 19 says find dy, okay, and evaluate dy for the given value of x and dx. So I'm going to first find dy. I'm going to take the derivative and then solve for dy. So I found the differential dy for part A. In part B, I'm going to plug in my desired x value and the little change in x after that to find out what the little change in y would be. And I get that the dy, the change in y would be 0.45. So for every 0.05 the x changes, the y changes at 0.45 at the x value